All right. So let me do it this way. I'm gonna no, actually I was gonna do it. I was gonna say let's do it in the calculator, but you can't because it'll use the one thing that you can't do. So the one caveat is you can't row swap. No row swap. Right. So the idea here is that we need to be able to get this in order to use LU factorization or LU decomposition, is to get it into an echelon form using row operations except for swapping rows. All right. So the issue here is we have a 0 to start off. All right. So let's see if there's any operations that we can perform that would at least get us going in the right direction. All right. So the first thing you would think, I guess, would be to do a quick negative R2 plus R1, I guess. I'm sorry, just a positive R2 plus R1. All right. If we could swap it, we would actually be pretty much done if we could swap the rows, but we can't. So we have to do other operations. All right. Another possibility would be something like negative R1 plus R2. All right. So if we assume that this is progressing this to get to a U, then we would want to come up with the L somewhere. So just kind of going back to what we did on our previous page, we have the U is the upper triangular format with the zeros below the main diagonal. The L is what we build based off of that information. All right. So we would have to go. We'd start with this guy here in building our L. We would assume zeros above the main diagonal, right? Because this is lower triangular. We divide, start in the first column. We would divide this by the pivot number, all right? So that would give us a 1. All right, so in that regard, we're fine, right? But then the next entry, so you divide every element in that first column by the pivot number. The element below that would be a 1 also. All right. So then we do our row reduction. We get it down to the next level. We have it in an echelon form. All right. We would have to negate the second row, but we can do that in a second. But the idea here is that we would then take this number and divide it by the pivot number in that column, ignoring anything above it. So we put a 1 there in the remaining entry. All right, so we have what we think is an L. Let me just check. And what we think is a U as a possible factorization. Now, it's supposed to be in n echelon form. It doesn't have to be in reduced row echelon form. So zeros below the main diagonal, that's pretty much it. Okay, so let's see if this pans out. So we followed the algorithm. So this is one way to show that it does not have the LU factorization. We used the technique and we just didn't get the right answer. So this is my L and this is the U. But you could have even stopped way earlier than that, right? Because the technique in LU factorization is to, in the process of getting the echelon form, we should be able to, based off of our original matrix, cancel out everything that's below that pivot number in the upper left-hand corner. In order to be in echelon form, you need to have something, you need to have a pivot in the upper left-hand corner for a square matrix. So if I don't have that, it's not going to work. The LU decomposition technique is not going to work. So based on the fact that there is a 0 here, it's all over, because if I try to cancel out the 1 there with a 0, not gonna happen. But even, let's say by some miracle we just invented new math and we were able to do that, we were able to somehow cancel that. Even in this step, let's say that we're somehow allowed to have 0 as a pivot number. This position is the pivot position in the LU decomposition technique. I would have to divide every entry in the column by that 0 in order, in order for the technique to bear itself out, in order for the algorithm to work. So I can't divide by 0, so it would not have the LU factorization, right? So, but in terms of the actual instructions, show, and here's a case where we're actually showing that it doesn't. All right. That's not to say it doesn't have other types of factorization. It just doesn't have the LU. All right. Can we come up with two matrices that multiply to 0, 1, 1, 1? Yeah, maybe. I don't know. Maybe not. But not using the LU type.